Hi everyone, we're going back to limits, and so just to review, right, at the beginning of the year we went over some techniques where we could solve limits where if you plugged in the number directly you would get indeterminate form. Right, so if you plug -1 in, we get 2 minus 2 on top, and then -1 plus 1 on bottom. We get 0 over 0. So we know that there's something else that we have to do. And so I would probably factor out the top. That way I can cancel these out. I end up with just the limit as x approaches -1 of 2 times x minus 1, which is just -4. Okay, at this point I can plug in my -1 and then there's no problems. I got rid of the denominator because this was the problem spot. Right, similar deal here. Now remember, if you're taking a limit to infinity, and the degree of your polynomial on top and bottom are the same, then you just compare your coefficients. And the reason why is because we can factor out an x squared on top and bottom and cancel these. And so I end up with the limit as x approaches infinity of 3 minus 1 over x squared over 2 plus 1 over x squared. And if I plug infinity in at this point, 1 divided by infinity is 0. So I get 3 minus 0 on top, 2 plus 0 on bottom, which is just 3 halves. Okay, so that's why we can just compare the leading coefficients. But if you didn't show all this work, that would probably be fine. Okay, and if you have a square root, remember you can multiply by the conjugate. So I'm going to multiply by the square root of x plus 2 plus 3 on top, the square root of x plus 2 plus 3 on bottom. Okay, and that will give me x plus 2 minus 9 on top. And remember, do not distribute the bottom. Right, we're going to keep everything separate. The reason being, a lot of times, this top will become this. Okay, so I have x plus 2 minus 9. That's the same thing as x minus 7. Right, and these will cancel. So I cancel out that problem spot. That's why I wanted to multiply by the conjugate. So I end up with the limit as x approaches 7 of just 1 over the square root of x plus 2 plus 3. So now if I plug in 7, I just get the square root of 9, which is 3, plus 3 is 6. So I get 1/6 as my answer. Right, so these are some of the techniques we went over to solve limits. And now we're running into something called L'Hopital's rule. So if you end up in indeterminate form, which we're going to define as 0 over 0 or infinity divided by infinity, then what you can do is take the derivative of the top and the bottom. Okay, you're not doing quotient rule or anything like that. You're just taking the derivative of the top and bottom as if they're totally different functions. Okay, and that's kind of cool. That just means that the limit of the ratio between your functions and their derivatives are the same, right? And you can keep going if it doesn't work the first time. Okay, so here I evaluate. If I plug 0 in, okay, I get 1 minus 1, which is 0, over 0. So I know that this is a candidate for L'Hopital's rule. So I'm going to rewrite my limit. I take the derivative. The derivative of e to the 3x is 3e to the 3x. The derivative of 1 is 0. And the derivative of x is 1. Right, and that's real nice, especially when this happens, because that gets rid of the denominator immediately, which is our problem spot. Right, so I plug 0 in now, e to the 0 is 1, 3 times 1 is 3. Right, same deal here. If I plug negative infinity in the way that it is, right, I get infinity on top, and then I get e to the infinity on bottom, which is infinity. Right, so I have infinity over infinity. So let's take the derivative. On top I get 2x. On bottom I get negative e to the negative x. Okay, and again, if I plug negative infinity in the way that it is, I end up with, well, negative infinity on top, negative infinity on bottom. Okay, so it didn't work the first time, let's do it again. Derivative of 2x is 2. Derivative of my denominator is going to be just e to the negative x. And And so now, if I plug infinity in, I get 2 over infinity, which is 0. Okay, so basically I had to take the derivative as many times as it took for my polynomial to go down to a constant, which is pretty common. Okay. So sometimes we gotta do a little work first, which is fine. So here, all I have to do is rewrite this as a fraction. So I have the square root of x on top and e to the x on bottom. Remember, if you have a negative exponent, you can bring that to the denominator. And so now if I plug in infinity, I have infinity over infinity, which is what I want. Okay, so now I could take my derivative. I have 1/2 x to the negative 1/2 on top. And I get e to the x on bottom. Remember what that means is I have a 1/2 on top. I have x to the 1/2 on bottom and e to the x on bottom. Alright, so both of my variables are now in the denominator, so if I plug infinity in, I have 1/2 divided by infinity times infinity, which is 0. Alright, here I have two fractions. All I'm going to do is combine them. So limit x approaches 1 from the right of x minus 1 over natural log of x times x minus 1 minus natural log of x over natural log of x over x minus 1. Alright, so I got a common denominator. I'm just going to combine these terms. Okay, cool. So now if I plug in 1 and evaluate, I definitely end up with 0 over 0. Okay, because 1 minus 1 minus the natural log of 1, which is 0, divided by 1 minus 1 down here, natural log of 1 is 0. Okay, so I end up with 0 over 0, so I'm going to take some derivatives. So we'll take the derivative of the top, and we end up with just 1 minus 1 over x on top. On bottom, a little more complicated because I have to do product rule, but it's totally fine. I have 1 over x times x minus 1 plus just natural log of x. Okay. I can simplify this just a little bit, so I'm going to go ahead and do that. Alright, that just gets rid of this product here. And so if I plug in 1 at this point, I still get 0 on top, I still get 0 on bottom. So I'm going to take the derivative again. Okay, so on top I end up with 1 over x squared. And on bottom I end up with 1 over x squared plus 1 over x. Okay, this is a lot better. So now, if I plug in 1, I get 1 over 1 divided by 1 over 1 plus 1 over 1, or 1/2. Okay, let's keep going. The last one, we have to do a little bit of extra work here to get it to look like a fraction. Right, so what I'm going to do is I'm going to state that all this is equal to y. Right, so I'm going to say y equals the limit as x approaches infinity of my function. Okay, now at this point, I'm going to take the natural log of both sides. This is very similar to when we did logarithmic differentiation. So again, I'm going to take the natural log of both sides. You can probably guess why, because I have this exponent here. Okay, now I can go ahead and bring my natural log inside of my limit. Totally fine. Okay, that does a lot of good things because now I can bring my x down. right? And then furthermore, I'm going to write this as a fraction. Now, this isn't immediately apparent why I would do this. But if you think about your end goal, my end goal is to get this to go to indeterminate form so that I can use L'Hopital's rule. Because right now that's the only strategy that I'd really have for this. And I can't really take the derivative of this the way that it is. I don't know how to take the derivative of something to the x. Okay, so remember, when we have something to the x, you take the natural log of both sides every time. In this case, if I have 1 over x, I get 0 when I plug in infinity. And then same thing here, I have the natural log of 1 on top. So I get 0 over 0. So this gets me in indeterminate form, which is a good thing. Now I can take the derivative of both sides. Sorry, not both sides. Now I can take the derivative of the top and bottom of my limit. So I still have the natural log of y on the left. It's equal to the limit as x approaches infinity of kind of long, complicated thing. Okay, so negative 2 over x squared over 1 plus 2 over x. So this is the derivative of my natural log function divided by the derivative of 1 over x is negative 1 over x squared. Right, so all this is in my limit. Now if we do some simplifying, right, we get 2 over 1 plus 2 over x. Because remember, when you're dividing by a fraction, the same thing as multiplying. So I can say that this is the same thing as multiplying by negative x squared, which cancels with this. Okay, that's how I simplified that. Alright, so this is much simpler now. If I plug infinity in, I have 2 over 1 plus 0, which is just 2. But remember, this was natural log of y we were talking about. So I can exponentiate both sides and say that y equals e squared. Alright, that's it for this. See y'all later.